All right. Coming up next, we're going to talk about how we can pick the right distributed database. I mean, there's so many databases and so many options from NoSQL to SQL to RDBMS to distributed ones. How do we pick the right one? All right. For helping us with this question, I would like to invite Tim Berglund, Senior Director of Developer Advocacy at Confluent. Hi, Tim.
Hello. I'll say good morning because it's morning where I am. That's a very parochial greeting, but hello. And if it's morning where you are, good morning. It's good to see you.
Good to see you as well. I do want to share one fun fact about you that you recently shared with me, and this is that you're a drone pilot, hobbyist, and also a photographer. And so you combine the two things, right?
Yeah. To me, drones are just flying cameras. So I like to get in the air and take pictures of things and take videos of, that kind of slow moving over a landscape, revealing new things. It's a lot of things are just inherently beautiful from that perspective. So it's easy to just capture beautiful things that way. And I also do some work as a still photographer. I do time lapses and video and things like that. So it's a hobby. It's an expensive hobby. It's a terrible life. Don't do it.
Well, sometimes you can combine the two and it creates, great pleasure. But if not, at least it's a fun hobby, right?
Yes, it really is.
Awesome. Cool. And I would like to invite Avishak Gupta as well to our virtual stage here. And Avishak is a senior... Hello. Avishak is a senior cloud advocate here at Microsoft. And fun fact about Avishak, so in between when he waits to finish his task or to provision a new cluster, he is doing pull-ups.
That's right. So just for folks who might not be aware, so pull-ups are like this, palms facing outwards, and chin-ups are this. Pull-ups are a little bit harder. So if you train your pull-ups well, so you automatically gain on your chin-up. So yeah, I like to do that when I'm building stuff or, like Adi said, waiting for clusters to start up.
That's
Shout
awesome.
out home fitness.
Yeah.
It's a good thing.
Working well in these times.
Right? Hard to get to the gym.
Exactly. Working very well in these times, like I said. Yeah.
Yeah, it connects well to the wellness podcast that Cheryl is doing. So that's exciting.
Yes, absolutely. Mm-hmm.
What idea. All right. Awesome. Team and Avishak, take it away.
All right. When we're done at 10 minutes after the hour or 5 minutes after the hour? I want to make sure we're talking. Something like that, right?
Yes.
Okay.
I think we have about 15 to 17 minutes. Yeah.
Good deal. All right.
We should be good. Yeah. All right. So thank you so much, Eddie. All right. We are going to try and unpack this relatively, complex topic in a rather short time span. So let's get right to it, right? So Tim, like Eddie mentioned earlier as well, there are a lot of databases out there and new ones popping up quite frequently, although not as frequently as JavaScript frameworks, but still. So could you help summarize this database landscape, the SQL, NoSQL, new SQL? I think it'll help set up the right context for the rest of our conversation. So
Absolutely. And I think the question, as Adi framed it, how do you pick the right distributed database? It's a trick question. You don't. If you pick a distributed database, you're building a distributed system. And as I always tell people, you failed already. It's a terrible thing to do. Now, of course, I kind of make my living in distributed systems, and I know we all do it anyway. But you just got to realize anytime you're going to the distributed world, you're entering, and it's commonplace now. It's like everybody is a distributed systems developer now to some approximation, and you're just entering a difficult world. You have to realize that. And these things are not popping up as often as JavaScript frameworks because that's impossible. Because of like fundamental physical limitations with the plank time and things like that. And also not as common as it was 10 years ago. I remember like in the new days of NoSQL, it seemed like every week there was a new post on Hacker News talking about some new database. And that was the time that we coined the term NoSQL, because at that time, there was a push to develop databases that scaled. Scale was often a thing that we talked about. We need to be able to make databases big. And to do that, we have to leave behind the relational model and the transactional guarantees that we're accustomed to getting from relational databases and enter this new world. So that was NoSQL. And kind of the winners from there 10 years later are things like Cassandra, MongoDB, Neo4j, definitely not relational. very different kinds of approaches to being a database and scaling. NoSQL refers to a group of databases that are relational, that present to you a relational model and transactional guarantees that we're used to, but scale in a horizontal way and use different approaches to solve that problem.
Yeah.
You may hear also my dog is interested in talking about this. She's like, probably another dog walking by the house, and she needs to let me know. It's very important.
All right, cool. Now, talking. So we spoke about these different varieties of databases: NoSQL, NewSQL, and of course, good old RDBMS. Now, I see a lot of organizations and companies who are rallying behind at least these open source databases and building what you call multi-model capabilities on top of it, right? And trying to combine the best of all worlds. So essentially, I can think of the Redis labs behind Redis, of course, data stacks for Cassandra, and there is Azure Cosmos DB in the Microsoft ecosystem, and so many others, I'm sure. So, and I'm sure the audience is going to appreciate your perspective on this topic around multi-model databases as well. So,
yeah, I am a little skeptical. I think the way things are shaking out is that the multi-model database isn't necessarily the solution. And you can see that even in Cassandra and DataStax. And I'm making interpretations from the outside. It's been almost 4 years since I've worked there, and I'm just looking at things from the outside. But it seems like the direction there is to say, you know what? No, Cassandra is the thing that people want, and the other kind of integrated read models of graph data and search and things like that, not so sure about that. Cassandra is the valuable thing. Is kind of how I perceive that. So it seems like a backing off of multi-model to me. And again, DataStax friends, stomp on me on Twitter if I'm wrong. Cosmos, here I am at Microsoft. I don't know Cosmos DB very much.
Don't ask me you don't have to talk about it. It's okay.
Yeah. I don't know super well, but Redis is doing a little multi-model, like they're doing a streaming thing. But again, I've just thought of them as it's multi-model in the sense that there's all these data structures, but there is a coherent vision that Redis gives you. Like it's this high-speed in-memory cache data structure server. And so it feels less multi-model to me and more like they're saying, well, no, that's our model. And what I see, the successful path I see is to, as we are all sort of now as a commonplace, we're distributed systems developers, something more like you pick the database that has the model and the performance characteristics that you need for a particular view of your data, and materialize a view of your data in that database. And so you have a product that's optimized to do that model well. And you might have 3 of them in your system, but each one is local to a service and just being itself. So I see multi-model as a system property, and maybe less of a successful strategy of an individual database product.
Right. That's interesting because to be honestly, yes, I find multi-model databases a little intimidating. But if I look at it the other way from a very personal perspective, it's like just learn one thing and be done with it. But I don't think that's feasible in the long run.
Yeah, you might still have to learn a lot of things, but like each service maybe has its own specialty.
Exactly. And if I think about Redis, now Redis has this property of or this characteristic of modules, right? It has these add-on features which you can sort of convert that. You can give that SQL layer on top of it, or AI, machine learning, so on and so forth. So that's interesting as well. A lot of databases, Postgres, it has extensions. You can do pretty much anything you want with it. Add distributed capabilities, add data structures like Redis has, for example, or JSON. So that's pretty interesting. But then yes, I still think they are intimidating, and these individual databases also have their place. But it's an interesting area for sure. All right, awesome. Let's talk about use cases a little bit. Now, I know there are a few scenarios where the choice is very simple, the choice of databases, at least for me, right? So if I look at it, if I need an in-memory solution for, say, caching or, PubSub or session store, for example, Redis is there for me, right? But can you help us understand these scenarios or use cases where things are not so obvious, those gray areas, those, tricky use cases? I think...
Yeah, and this is another thing where if we try to reduce the universe of discourse to a few things, I mean, there's a lot of databases in the world, but broadly, There's relational databases. There's Cassandra. We'll say as the in terms of open source things that get big. There's Cassandra. There's Mongo, and I think Neo4j as the king of graph. And again, like you said, it's usually pretty obvious if you need a graph database. Like people maybe 10 years ago were saying, hey, everything's a graph. No, but there are graphs. And when you have a graph, you need that. That's obvious. I think a lot of this comes down to scale. And in my mind, anyway, I know this is simplistic, but if you really have a need for a big giant database, then you're going to need to go to something that's built for horizontal scale, like Cassandra or one of the cloud native lookalikes. Every cloud provider has a thing like that,
Yeah.
But in terms of the open source things that you can run in the cloud, that would be the one. And because you have to go big, right? If you don't have to go big, don't, because there are trade-offs for that. There are compromises you have to make. There are things that you want to do that you won't be able to do. So there's the one, like if you're big, if you're not, don't. And then that kind of leaves you. And the interesting thing I see is that since NoSQL began to now, we use the word microservices now. Nobody was saying that 10 years ago. It was not a thing. And there's a pressure to make smaller applications. And I think that's downward pressure on our database size as well, because we want now service local databases. So it feels like a lot of the time you kind of just want a relational database local to your service, and scale is not this huge thing. Sometimes you want that to be Mongo, and I see those as easily tradable off things. Mongo's scale has slightly automated scaling properties and a different data model, but it's still probably going to tend to be the service local kind of thing. And so I really just see, if it's not an obvious need for something that's not relational, and you don't have a preference for Mongo, it's Postgres or something, and it's a little database that parks inside a service and does its job inside that service. Any number of exceptions to that in the real world, like I said, but
exactly.
I think that's where I see things going.
Yeah, you made an interesting point there. So about microservices, especially because microservices also bring about this concept of each database for its own service, right? So you may have that polyglot database scenario as well, right? Not in all cases, but very much a possibility there. So that's another thing to contend with, I guess. So you might end up using a combination of multiple databases if your scenario so demands, right?
Yes.
Yeah.
And I think that's entirely appropriate to, you get different services exposing different views of some core set of facts, and a polyglot approach to databases, each database being service local is great. That's we didn't just describe CQRS, command query responsibility segregation, but we sort of started to, and so that's that set of ideas I think apply more and more to the way people are solving these problems.
Yeah, event sourcing, CQRS, that's right.
Exactly.
Yeah. All right, awesome. So you're going to like this next question, Tim, for sure. Now, this is, at least in my opinion, slightly debatable, at least, the conversations which I've had, but I'll open it up for you. Now, is Apache Kaska a database?
I've never gotten that question before, so I'm blindsided.
Really?
Ladies and gentlemen, no, it comes up all the time. So short answer and long answer. Short answer is no. Long answer is no. But I think of it as a database construction toolkit. So if you go to Kafka looking for a database, you're going to be sorely disappointed. But if you view the system that you're building, let's just suppose it's microservices and it's some large distributed application, you really start to view that as your custom-made distributed database. Kafka is the commit log that forms the core of that database, just as a write-ahead log forms the core of, every database you've ever used. If you're not a person who was involved in databases in the very early days. So database construction toolkit is what I would call it.
All right, awesome. So that makes sense. So many similarities, like you mentioned, right? And especially the fact around similarities between Apache Kafka and databases, and especially the
Yeah, and
Well,
that's just, I think, such an important model that log is remembering the core set of facts that are mutating your system, and then you do computation over that and build views of that and materialize views of that using all these databases we were just talking about in their own services.
Yeah, absolutely. Okay, so you had mentioned Cassandra, Mongo, and Graph, and Neo4j, and the fact that it is in that Graph database category. Now, if you think about Graph, right, it is its own niche area, right? Now it's easy to figure out when to use it. At least at least in my case.
Yeah.
But when I think about Cassandra or MongoDB, I personally see a lot of overlaps, and I'm assuming other developers too, right? So can you help us understand, which one to pick and when between Cassandra and MongoDB? If that's even a valid question,
It is. Well, no, it's a question that comes up. I get it less than I used to. I used to get that question a lot. And again, I think scale is the answer. And I want to be careful to be fair to Mongo here, because this could be insulting to Mongo people. Mongo is a single leader architecture, right? When you do a write, there's one place the write goes. And of course, you need to do read replication to scale reads. You need to do sharding to scale writes. Like, everybody knows that's how you do those things with that kind of architecture. And Mongo automates that so that it doesn't suck, because historically it sucks to do those things, right? And Mongo wraps this nice layer of automation around that, so it feels like a thing that scales out better than the architecture would suggest, because the architecture is not, there's nothing fundamentally scale out about the way writes are managed in Mongo. Cassandra, there is. So it's built to scale horizontally, to manage consistency across regions, data centers, cloud providers, all that stuff's built in, so that if it's a scale problem, from the ground up, Cassandra is designed to do that well. You make trade-offs for that. So your life as a developer using Cassandra is less pleasant. Your life as a developer using Mongo is more pleasant. So if you have a radical scale need, it's probably a Cassandra thing. If you have a little bit of a scale need, it's going to be better with Mongo, but not. You're probably just not going to get to Cassandra sizes. It's not built to do that.
Right.
And again, you get things for that, so you'll enjoy life.
Yeah. CQL and the entire concept of denormalizing data in Cassandra, that's a thing to learn, I think, with practice.
Thing to learn, and it can be done, but you have to learn it. And
Absolutely. All right, so I'm going to take care of time as well. So one last question, Tim, before I let you go. So tell us about some of the exciting cutting-edge database technologies which you think we as developers should keep our eye on.
Cool. So in my world, I already said Kafka is not a database, and I meant it. But there is a neat kind of database-y thing growing up around it called KSQL DB. It describes itself as the event streaming database for Apache Kafka. It's not, again, if you go to it like, oh, I don't need Postgres anymore, I have KSQL DB. No, that's not true. But there's this new category of, look, if I've transitioned my thinking to event-first thinking, which is what I was describing a minute ago with services and Kafka as being this log upon which all your other databases and services are built. There's certain kinds of things that you're going to find yourself doing in those data stores where you're having to reinvent a lot of the same functionality and over again. KSQL DB is saying, hey, in between raw stream processing and relational database, there's this other thing that doesn't take the place of raw stream processing, doesn't take the place of databases, but it's this other category, brand new category. I don't know what's going to happen, but it's extremely interesting, and I think it deserves everybody's attention.
Definitely does. So if you already haven't, please go check out KSQL DB for sure. All right, awesome. I think that's it about, we have this much time. So thank you so much for joining us, Tim. It was a pleasure having you. It's back to you, Eddie.
Great to see you, Abhishek. Thank you so much for this.
Cheers.
Thank you, Abhishek and team. It was super insightful and interesting to learn. And I'm excited about KSQL DB. I remember, I think 8 years ago, no, not 2 years ago, I published an article about why Kafka is not a database. And I'm curious to see the difference, how it evolved and how it looks like. Well, it was in 2018. 2020 is a whole new year, and 2021 it's about to kick off. So who knows, right? Magic can happen.
That's right.
So I'm looking forward to learn more about KSQL DB and what we have in store. Again, if you have any questions, you can always post them up on the chat on the YouTube channel, or going into our office hours on dev.to. You'll see this box where you can scan it, the QR code, scan it, and go and ask all your questions. Thank you, Team and Abhishek. Again, it was lovely to have you with us today.
So great to see you. Thanks for making me a part of this.
Yeah, awesome. Awesome. Take care. Bye.
Take care, everyone.